Hello, Professor. This is Alberto Martinez with the demo for Project 4. So first off, we set PLL equal to 80 megahertz. So in order to set the system clock for the TM4C123, and we are also initializing UART1 and UART5. So UART1 connects between the serial terminal and the Bluetooth module, which will then send that signal to the first microcontroller. And that is set to be 57,600 for the bit rate, and it is an 8-bit word length with an even parity and one stop bit with 5 O's turned off. And then UART5 is the same type of communication, so 57,600, and is able to communicate between the first microcontroller and the second microcontroller in order to send data back and forth. So we then go into initializing the SysTick initialization, which in this case didn't really matter too much. However, if we look at this SysTick over here, I'm initializing it to be at a frequency of 262 hertz. So that is set in order to set the frequency of the speaker and the wave that is going to be displayed. So every single time something gets refreshed or the speaker is being changed for the wave, it is going to be at that same frequency right there. So same thing, PWM doesn't really matter right now, and for the first microcontroller, the first thing that's going to come out is the serial terminal is going to put out the title and then give us a prompt. So in the case that the input is set between 0 and 3, we're going to send the information that is being displayed output by the DAC or the speaker. We're telling the serial terminal that this is what we're gonna be outputting, and we're gonna send the character corresponding to that to the second microcontroller, again via the use of UART5. So once we get that data on UART5, as you can see over here, we have a couple other initializations. So we initialize the DAC, which is up here, and you can tell that it's a 8-bit DAC. It's set in from this is from PA7 to PA0, actually, and it goes on port B. So all of port B will get that data and then output it by filtering it through that DAC. So that data is here actually. You see that corresponding to 4, 5, 6, and 7, we will output a specific wave depending on that DAC output. And those waves are created by these like constant tables here for sawtooth waves, square wave, sine wave. And we are basically indexing through that wave every single time, and since it's in the SysTick handler here, it gets refreshed every single time that the interrupt occurs. And so correspondingly, we're going to take out that square wave and then just index through it in order to create our sound through our speaker. So what else do we have here? We have, oh yes, we have the SD773 initialized here. What that will do is allow us to use the functions on the SD7735 library, and so we're able to use those to create different kinds of displays on the screen. So with that, we're basically this just sets the rotation and clears it in order for it to be a clear screen to begin with, and we're going to tell our screen that it's ready to draw, and that's going to be displayed on the screen. And the first thing we're going to do here is read the character that was sent from the first microcontroller to the second, and with that we are going to use that data to choose a animation or like the pix. We're essentially telling the screen what pixels we want to light up and in what color using the functions in that library for the SE7735. So that is the basic rundown of how the code is working. So in order to show you, I have here the communication between this serial terminal right here, which is in my laptop, is going through Bluetooth onto this Bluetooth module right here, then hopping over through UART1 to the first microcontroller, which I set the LED on specifically just to tell that this is the first one, and then it's hopping over through those UART. No, the Bluetooth connects to the MC microcontroller through UART5, and then this microcontroller connects to the second microcontroller through UART1, and then with that we're able to read the data from the first microcontroller that was sent all the way from the serial terminal and display either image on this LCD screen, or we're going to change the wave that is going to be outputted from this speaker. So with that in mind, we have here, and if we put 0, for the LCD, we are going to see that this has changed over here. So if I go to 1, 2, and 3, and we can just cycle through them. As you can see, I'm inputting over here and changing the values. So if we go back to 0, for example, that should be that. So on top of being able to do the display, we also have 4 through 7, which is the waves. So if I hit 4 here, we are going to get output. I hope you can hear that. Then 5. So corresponding, there should be a sine wave, square wave, triangle wave, and a sawtooth wave. And as you can see, well, we can't see the waves, we can hear that while the pitch stays the same, the form of the wave changes along because of the DAC values and the values provided to it. So yeah, that's the basic gist of it. And yeah, have a good day. Thank you.